In this video, we're going to work on the ALEKS problem called Choosing a Graph to Fit a Narrative Advanced. This problem is going to give you two scenarios, and each scenario is going to have four possible graphs that reflect the situation of that scenario, and your job is to figure out which one of these graphs accurately reflects the scenario. So you're going to have to read carefully. You also need to pay attention to the axes on these graphs because they are different from one problem to the next. So the first problem is telling me starts by biking slowly at a constant rate, then picks up speed, and then maintains peak speed for the rest of the workout. So I'm going to start with this. Starts by biking slowly at a constant rate. That means that I have a constant speed. That means that I'm not speeding up or slowing down initially. So at the very beginning of the graph, the beginning portion of the graph over here, where the beginning segment of our time, if I'm at a constant speed, that means that my graph is flat. I don't know how else to describe it. We have a flat graph, so our speed, this is a graph that shows speed is decreasing. This graph shows that speed is decreasing. That's not what we have going on. It says initially the speed is a constant right there. And then it says, I'm just going to kind of move this out of the way. It says that she gradually picks up speed. So that means that the speed is increasing, which means that our graph would have a positive slope, which we can see right here. So this would be increasing speed. This graph over here, speed is decreasing, and then it increases again, but it doesn't tell us anything about her speed decreasing. So I'm going to go with this graph right here, but let's finish reading what it says. Speed increases, positive slope, until she reaches her peak, and then she maintains this peak speed. Again, the speed, if it's being maintained, that means that it's not changing, it's staying constant, flat. So this graph definitely reflects the scenario in this story. Here's our second scenario. We have somebody that's walking to school at a constant rate. Midway, she stops for a few minutes to talk to a friend, and then she continues walking to school, but at a slower rate. So we got to be a little bit careful with this graph because it's not graphing her speed versus time. If it was graphing her speed versus time, we would use the same type of strategy as we used up here. This graph is her distance to school versus time. So she is walking to school at a constant rate, which means that she should be getting closer and closer and closer to school. In this graph, she starts with a distance to school equal to 0. So this graph means that she is starting at school, not walking to school. In this graph, she is walking away from school. Her distance is getting larger and larger. So this graph doesn't even apply to the situation at all, and actually neither does this one or this one. That makes it kind of easy. So all three of these graphs, she starts at school and walks away from school. This problem is telling us that she is starting somewhere else and walking towards school. But let's go ahead and read the rest of the problem and make sure that it lines up with what we picked. So it says she's walking to school at a constant rate, which means that her distance to school is going to be decreasing because she's getting closer and closer and closer to school, and it's going to be decreasing at a constant rate because she's walking at a constant rate. So we're going to see a nice linear decrease. And then it says she stops for a few minutes to talk to a friend. So during that time when she's not walking, her distance to the school is not changing because she's not going anywhere. So the distance stays the same for a while. And then she continues to walk to school, but she's walking at a slower rate. So here she continues to walk to school because she's getting closer, but she's walking at a slower rate, which means that in this case, the slope is not quite so steep. So here she's walking pretty fast because she's covering a lot of distance in a short amount of time. Here she's walking slower because she's covering less distance in a longer period of time.